everyone, we're going to evaluate the definite integral from 0 to t divided by 2 of sine of 2 pi little t divided by big T minus alpha of dt. We're going to use the substitution rule for definite integrals, and we're going to go ahead and start using, let this be u. So we're going to let u equal 2 pi t divided by t minus alpha. So if you take the derivative of u with respect to little t, that's just going to give you 2 pi big T. You cross multiply this, and you can put the big dt there. Take it away here. Now we're going to have to solve for dt. So I'm just going to multiply both sides through by big T divided by 2 pi. So this is going to be dt equals big T divided by 2 pi du. Now we have everything done except our, we have to adjust our limits because we're not going to substitute back in the u, so we have to change our limits. So if t is 0, then what I'll get is u. So if I put a 0 in here, let t equals 0, I'll get u equals negative alpha. And if t equals, what's the other one? Big T divided by 2, then that's going to give me, this u is going to be pi minus alpha, because the 2 and the big T will cancel. All right, so you're just going to be left with pi here when you plug in big T divided by 2. So let's see what we can substitute here. So we have a new integral. The limits are going to be from negative alpha to pi minus alpha. And then we have sine of u. And our dt equals this. So that's going to be big T divided by 2 pi du. All right. Now let's go ahead and evaluate this. So what we're going to get is, I'm going to go ahead and, this is a constant. So I'm going to pull that out. T divided by 2 pi. The antiderivative of sine of u is negative cosine of u. And we're going from negative alpha to pi minus alpha. All right, so all we're going to have to do is evaluate this, and I'm going to substitute in these values. Start with this one. So let's do that. I'm going to go ahead and also pull out this negative and pull it out and put it here. So I'm going to write that again. So we have negative big T divided by 2 pi. And then this would be cosine of u. And we're going from negative alpha to pi minus alpha. All right, so let's substitute and evaluate. So always take this one first. This is going to be cosine of pi minus alpha. Then we have minus cosine of negative alpha. All right. So this gives me negative t divided by 2 pi. All right. This right here, using our sum and difference formula, is going to give you negative cosine of alpha. And I know what you're saying. You're saying, well, how do you know that? Well, I'm going to show you the sum and difference formula for this on the next slide. If this is an identity for sum and difference formulas, I will show you that on the next slide if you want to wait around for that. Now, also, cosine's an even function, so I can just make that positive. So now we have another negative cosine of alpha. So this is going to equal negative t divided by, let's put equal here, 2 pi. And this is going to be minus 2 cosine of alpha. Two negatives make a positive. So your final answer is just going to be t. The 2's will cancel. So you have t divided by pi cosine of alpha. Okay, like I stated before, if you don't know why this part here equals negative cosine, I'm going to show you that now. All right, so we're going to use the sum and difference formula. We had cosine of pi minus alpha. That has this form here. This would be like your, let's call this A and B instead, because we already have alpha. So this is like A minus B. So you write it out, you're going to get cosine of pi, cosine of alpha, plus sine of pi, sine of alpha. And what happens is cosine of pi is -1. So you have cosine of alpha here. Sine of pi is 0. So this just goes away, and this gives you your negative cosine of alpha. So that's how we did the identity for this one. So anytime you have a cosine of, let's say, alpha minus beta, that's just going to be negative cosine of beta. And that's it. Thank you. Have a nice day. Bye-bye.